On today's interactive virtual field trip, you will be answering the following question. What depositional environment existed between the red narrows of Spanish Fork Canyon, Utah to East Helper, Utah during the Cretaceous period? Prior to going on our virtual field trip, as a class, we must understand how environments are investigated to give us clues of the past. First, we must take a look at Handout 8 to understand the clues we can see in exposed rocks to tell us what existed in years past. Looking at your handout, which you see here, particular attention needs to be paid to the following areas: textures, sedimentary structures, and sedimentary rocks for the following categories: alluvial fans, meandering streams, deltas, barrier islands, beaches, tidal flats, and deep marine. Now that you have an understanding of the depositional environments chart, let's put it all into a visual. Starting at the top, generically speaking, are glaciers. Glaciers are ancient ice packs that are sometimes moving and oftentimes melting. The runoff from the glaciers carves and carries material downstream to where it widens. At the widening point, the runoff slows, dropping its material cargo, and over time creates an alluvial fan. Alluvial fans are quite common anywhere you have a narrow pass that descends and widens at the bottom. If you were to dig down into an alluvial fan, you would find that the materials are poorly sorted. In years of faster water flow, larger materials are carried down and deposited. At lower flow rates, smaller, finer material is deposited. Lakes and ponds are formed in low-lying areas, often pooling the water runoff from higher elevations. When lakes flood, streams are created. Streams are one of nature's wonders. When they are moving fast, they can cut mountains and move large materials such as boulders and trees. However, a slow-moving meandering stream will move small grains of material and sand off the corners of larger stationary material like rocks. Sometimes, along a stream's travels, a stream may empty out into a low-lying area with little drainage and plenty of water-holding material, thus creating a swamp. You may not know it, swamps are a valuable resource for future generations. Today's coal beds were yesterday's, as in a few million years ago of yesterday's swamps. Beaches are the meeting point between the ocean and the dry land. While not readily apparent within our lifetime, the beach is in a constant state of change between settling and becoming rock or breaking down back into a sandy state. Deltas are much like the alluvial fans we discussed earlier. An alluvial fan forms when a river empties from a canyon. A delta forms similarly, but when a river empties into a body of water. Tidal flats are the overflow for a body of water. As the tide goes up and down, it can spill over into low-lying coastal areas. Sedimentary environments that existed in previous deep marine will leave behind today's sandy basins and trace fossils. Now that we have built some background knowledge, let's begin our adventure. Our first stop on our adventure is Diamond Fork Sandstone. The formation is from the Pennsylvanian period and is approximately 20,000 feet thick. Geologically speaking, this middle-aged formation is approximately 245 to 544 million years old, and while it may look like just another rock on the side of the road, it provides evidence that a hinge-line fault exists. A hinge-line fault is where two plates come together, and due to immense pressure, one plate rises and one plate falls, causing one plate to dive under the other. The resulting low point between the two plates is perfect for sediment to collect. This is known as a passive sedimentation effect. The accumulated sedimentation material is softer and will erode much quicker than the material found here at Diamond Fork Sandstone. So what does this all mean in simple terms? Utah is literally crushing itself. The area on the east side of the hinge line is pushing westward towards the Great Salt Lake. On the other side of the hinge line, where the Great Salt Lake is located, it's pushing eastward towards the Wasatch Mountains. All of this in combination is why we have the Wasatch Fault Line and the potential for some major new landscaping courtesy of a great earthquake. Before we continue on our journey, remember that all of the clues we discuss are vital to answering the original question. Now, in the short travel of approximately 10 miles, the land formations have changed drastically. We have time traveled from the Pennsylvanian period of approximately 245 to 500 million years ago and drove into the Jurassic period of 159 to 206 million years ago. So what event happened to expose the layer of Navajo Sandstone? The spring of 1983 started out with a rapid warming. Combined with a higher than usual rain and snow, the mountain couldn't keep itself together and a massive landslide resulted. This is what it looks like today, with the Navajo Sandstone poking through and giving us one more clue to the geological layers that lie below. A little history on this slide. The Thistle area used to be a thriving mining community until the mountain moved and toppled right over the community that existed. As you can see, the landslide buried a community, and this roof is the only proof of the house buried below. This landslide moved at a rate of 3.5 feet per hour and dammed Spanish Fort River in 2 days, thus creating Thistle Lake. However, Thistle Lake dried up, and today we see the remains of the landslide. This gives us further clues that we are moving through time due to the exposure of the different layers that were deposited. Physically turning ourselves around to the north side of the road, we can see the exposure of the Carmel Formation, which existed during the middle part of the Jurassic period, approximately 190 million years ago. Next stop for clues, the Cretaceous period. Everyone pay close attention. We're about to get our first clue to answer the question. What depositional environments existed between the Red Narrows of Spanish Fork Canyon to the city of East Helper during the Cretaceous period? Your first observation here at the Red Narrows are the poorly sorted rocks. The second observation is the rounding of the rocks varies. You will find the larger rocks are well rounded and appear to have evidence of weathering, while the smaller grains of material, the cement, is not well rounded and tends to be more angular. This tells us there was a time when the water was moving fast enough to carry the material away before it had time to round. Some further observations that can be made is the primary bedding plane that has a downward slope. While the color of the rock is a reddish color, and the dominant rock type is limestone and sandstone. At this point, take a moment to review the evidence presented. So far, we have observed poorly sorted rocks, variable rounding of rocks, inclined bedding, and red in color. Now, let's take a moment to see if we can determine what the depositional environment is from the chart provided earlier. Now that you have all had a moment to review, if you came up with alluvial fan, you would be correct. The combination of flash floods and debris flows created the alluvial fan. Now let's continue on our journey to see what other environments we can find until we reach our stopping point at the city of East Helper. On this part of the field trip, we will continue to gather information to determine our depositional environment here at our Castlegate stop. Looking at the picture behind me, the following observations are made about the material found at this location. The analysis of the material will lead us to the observation that the rock is more wacky than quartz and could possibly be considered mud rock. The grains are fairly well sorted and well rounded. The sedimentary rocks are layered and the grain sizes are constantly changing. The type of rock that is found here is sandstone. In this picture, the rock formation shows a cross-section of a possible stream. Once again, giving us a clue of what type of environment we may be looking at while visiting the Castlegate stop. Let's take a minute to refer back to our chart and see if we can determine the environment from our observations. After having some time to review the charts, if you came up with meandering stream, you are correct. The forces that cause a meandering stream are high energy channels caused by the movement of water and debris, creating a point of deposition of sediment on the point bar while erosion is at work on the cut bank, creating a shifting channel position. Now, prior to leaving the Castlegate stop and moving on to our power plant stop, the following information will be beneficial in determining our next depositional environment. The Green River material was deposited during the Eocene age. The Green River Formation contains a lot of carbon deposits or organic material. Remember, finding carbon is evidence of plant life from previous times. Large reserves of hydrocarbons are found in Utah, Wyoming, and Colorado. The Green River was only 1,000 feet above sea level during the Eocene period. The Flagstaff limestone creates a flat slope. And finally, limestone beds are separated by shale. We have arrived at the power plant stop. Look around you in every direction, and for miles all you can see is swamp, about 240 million years ago. How do we know? This strip of black material in the rock? It is a hydrocarbon, or better known to us as coal. Swamps are a great collector of organic material. Organic material, such as plants, animals, and anything living, can collect in the bottom of the swamp bed. Give it a few hundred or thousands of years of accumulation, and that's quite a pile-up. Add in a little bit of earthquake, or maybe another cycling of the Earth's climate to a warmer period, and the swamp could drain. Add a dash of additional dirt for weight and pressure, and now the final ingredient, patience. Say for millions of years, and we end up with this, coal. From all of the coal around the world, we know that the Earth had a really warm, swampy environment for quite some time. And because of this, we have our most abundant energy supplier, coal. So you could think of this coal power plant as a swamp processor. Now, just a couple hundred feet east, we have two new depositional environments that are important to us. Breaking from our geological hunt, I will tell you what they are because, unfortunately, I just can't show the details needed for you to see it. This formation has the following traits. First, it is in two layers. The bottom layer is darker, fine-grained, and well-sorted. To put it crudely simple, it's a mudstone. The top layer is lighter in color, well-sorted, rounded material, and has ripple marks showing. The material contains trace fossils and would be considered a beach. So what do you think that makes the darker underside layer? A tidal flat. And now for our final stop. At this location, the observations are as follows. The material is well sorted and fine-grained. Color is gray to black, and the rock is a shale or a siltstone. We also find trace fossils such as cephalopods. At this point, we will pause for class discussion to identify this environment. And while you're at it, go ahead and answer our question of what depositional environments existed between Spanish Fork Canyon, Utah and East Helper, Utah during the Cretaceous period. I hope everyone has had enough time. Let's go through it from the top. First, we encountered the Alluvial Fans at the Red Narrows. Next, we moved on to the meandering streams at Castlegate. From there, we visited the prehistoric swamps of the coal strips and took a quick jump over to the nearby beaches and tidal flats, bringing us to our final stop here at East Helper, where we find the deep marine. So now that we have the question answered, just for grins, what do you think created these features? During the Cretaceous period, there were a number of high-energy events such as large-scale water movement, sedimentary movement, and of course the constant law we cannot ignore, gravity, which was pulling everything downward. Until next time, just keep rocking on. Get it? Rock on? Oh, come on. Really, rocks. Geology? Come on, rock on. I don't know, that didn't work. See, you got to do the thing.